Dear students, today we will study about the notion of the potential energy. We know the mechanical energy. The two types of the mechanical energy are the kinetic energy and the potential energy. Kinetic energy of a body is due to its motion, whereas the potential energy of a body is due to its position or change in shape or configuration of the body. Potential energy can be defined as the energy possessed by a body due to its position or change in its shape or configuration. The potential energy is a stored form of energy of a body. The potential energy is possessed by a body when some work is done on it, and a body can do same amount of work equal to its potential energy. Here, if we see that a body of mass m, if it is at earth or on the surface of the earth, then its potential energy, if we consider as 0, then if we take it to this height, then due to the change in the position of the body, it possesses the potential energy. Now, why it possesses the potential energy? That should be known to us, that a body from the surface of the earth cannot be lifted up at its own. This is very common observation, that nobody can raise its height from lower height to the upper height, from lower point to the upper point, from lower position to the upper position without doing any work. That means at its own, it is impossible for a body to raise its height, to increase its height. Some work has to be done in order to change its height. And this work is stored in the form of the potential energy. In nature, everything has the tendency to remain in the minimum potential energy level. Whatever the type of the things, everything. This body also has the tendency to remain in the minimum potential energy at its own. But if we take it to the higher position or at a height, then we have to do work, and this work is against the force of gravity, and hence this amount of work, whatever we do, is stored in the form of its potential energy. There are so many examples of potential energy due to the change in the position of the body. So this is the first example: a body kept at height possesses potential energy. We can take the example of an aeroplane flying high in the sky possesses potential energy due to its position. It also possesses kinetic energy due to its motion. Then another example: water stored in dams possesses potential energy due to its height. Deliberately, the height of water is increased in dams so that when it falls on the turbine, it can do the work which is useful in generating the electricity. Water stored in overhead water tanks also possesses the potential energy. We know that water flows from higher level to lower level. Any liquid flows from higher level to lower level. So, in order to supply the water at heights, we have to store the water at heights. That's why to supply water, it is stored in overhead water tanks because it cannot raise its height at its own. Another example, very interesting and very simple example of pendulum. I think you all might have seen the pendulum. Now this is the mean position of the pendulum. This mean position means the lowest possible position of a freely suspended pendulum. Now, if it is displaced, say, to a small angle, or there is a small displacement, then the change in the height takes place, and due to which the raise in the height takes place and it possesses potential energy. And if it is released, it can come back, but due to inertia, it overshoots its mean position and starts oscillating. So these are the examples, some of the examples of potential energy due to position. Now, we discuss some examples of potential energy due to change in configuration or change in shape of a body. Can you give any such example? There are so many examples. A few we are taking. You have seen the rubber band. If it is stressed, its position is changed, and a stressed rubber band possesses potential energy. This is also common observation that a stressed rubber can do work. Another example, a stressed bow possesses potential energy due to change in its shape or configuration. A stressed bow, when released, it can throw the arrow because it possesses the potential energy which converts into the kinetic energy of the arrow. Another example of the spring, a compressed or stressed spring possesses potential energy. When a spring is compressed, we have to do work. When we stretch a spring, we have to do work, and this work against the restoring force is stored in the form of potential energy of the spring. Now, gravitational potential energy. We discuss about the gravitational potential energy. Suppose a body of mass m is at ground. At ground, the potential energy, the reference of the potential energy of the body is taken 0. Now, when it is taken up to a height h, then we have to do work against the force of gravity. And this force of gravity is equal to mg, and it acts in the downward direction because F is equal to ma. Here, instead of a, we have taken g as the acceleration due to gravity, and it is acting downward. Now, to lift the body, to raise the height of the body to h, we have to do work against this force of gravity. So, the applied force in the upward direction, but this is equal to mg, and the displacement is also in the same direction. So the angle between the force, applied force, and the displacement is zero because they are acting in the same direction. But in order to lift the body to a height h, we have to do work against this force of gravity. So, as per the definition of work done, it is the scalar product of force and displacement. So here it is equal to Fs cos 0. Instead of theta, we can write 0 because force and displacement are in the same direction. So this is equal to Fs. Now instead of F, we can write mg. Now this should be clear. Against the force of gravity, we have to take the body. So equal to the force of gravity, we have to apply force to raise its height, and the displacement is equal to h. So this is the total work done in raising the height of a body of mass m. Now this is equal to the work done equal to mgh is stored up in the form of the potential energy of the body. So we can say the potential energy of the body is equal to U is equal to W, that is equal to mgh. More the height, more is the potential energy possessed by the body. Less the height, less is the potential energy possessed by the body. And potential energy also depends on the mass of the body. More the mass, more is the potential energy possessed by the body. As we say that for more mass, we have to apply more force to lift it. That means more work done. And this amount of energy is a stored form of the energy. The body can do the same amount of work equal to its potential energy.